So this is another example of rationalizing the denominator. It's a different type. In this type, I have two terms in the denominator. And you could have either one of those two terms be a square root or both of them be a square root. This is used for square roots, not cube roots or fourth roots. There's other special rules you could use for those, but we don't do them. And so the trick here is to multiply the numerator and denominator by the conjugate of the denominator. Remember what conjugate is. It's the same thing but with a different sign in the middle. Same binomial but a different sign in the middle. So I write that out. I put those in parentheses because you want to multiply the whole numerator and the whole denominator. And I'm multiplying it by square root of 2 plus 3, which is the conjugate of square root of 2 minus 3. Okay? And then what happens on the numerator, you just have to multiply everything out, which is why we practiced that before. Right? So I just multiplied the 2 times square root of 2, right? 2 times 3, square root of 6 times square root of 2, that's square root of 12. Square root of 6 times 3 is 3 square root of 6. The square root of 12 will simplify some, but I can do that the next step. Then on the bottom, I get 2 minus 9. That's it. I don't have to multiply each one out. Why? Because this is a difference of two squares. When you multiply two conjugates, you get the difference of two squares. You get the first one squared, which is 2, and you get this minus, always minus, and you get the last one squared, which is 9. So I know it's that. See, so that's a rational number. So I'm using this formula, right? The difference of two squares. So that's just to remind you. That's all I'm using there. Difference of two squares is actually used quite a lot. So all I'm doing here is I'm simplifying the square root of 12. 12 is 4 times 3, and the square root of 4 is 2. So I get 2 square root of 3 here. 2 square root of 3. Then the rest of these 3 I just pulled over. None of these are similar terms. That's a square root of 2 term. That's an integer term. That's a square root of 3 term. And that's a square root of 6 term. So you can't combine any of these. And then the denominator, 2 minus 9 is negative 7. And I put the 7 there and I put the minus in front. Because we don't like to have negative on the denominator if there's a single term. Because that's considered unsimplified. So I just put the negative in front. I don't want to put it on top, which would be legal, but I'd have minus, 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 and I just don't want to do that. It's much better to just put it in front. Okay? So that's the answer. It's not easier than the original. It's not really simplified from the original. It's just for some reason, this would come up in a bigger problem, where for some reason you didn't want the square root in the denominator here. So this gets rid of it. It doesn't make the whole expression simpler. It actually makes it more complicated, right? But sometimes you want that. You don't want it more complicated. You just don't want, sometimes you don't want a square root in the denominator. Okay. This last little piece here is also in assignment 3. It's rationalizing the numerator. This is the exact same idea as rationalizing the denominator, except now we want to get rid of the square roots in the numerator. And this is used a lot in calculus. If you ever go that far with math, this is used a lot there. It works exactly the same way as rationalizing the denominator. It's just that what determines what you multiply by is whatever's in the numerator. So I want the conjugate of this, square root of 3 plus square root of 2, on the top and the bottom. And then that'll rationalize the numerator because of the difference of two squares formula. So it'll be square root of 3 minus square root of 2 over square root of 3 minus square root of 2. Just writing out the original, parentheses there. Okay, and this here is the conjugate of this one. And this has to be the same as this. Okay, the top will be 3 minus 2. How do I know that so easily? It's a difference of two squares formula. So you've got this squared, which is 3, always minus, it's a difference of two squares. This squared, which is 2. So the numerator is going to be 1, which is pretty nice. The denominator, I could leave factored in theory, but I multiplied it out. And that's a perfect square because these two terms coincidentally happen to be the same. That's just a coincidence. So I use this formula. So the first one squared is 3, then twice the product of these two, which is negative 2 square root of 6, right? And then the product of these two, which is positive 2. So now I want to combine these, the 3 and the 2, and the 3 and the minus 2. And I'll be done. So I get 1 over 5 minus 2 square root of 6. Now, it said rationalize the numerator. Notice the numerator is a rational number. It's actually an integer. The denominator, when you do this, the denominator will usually have a square root in it. That's the way it's supposed to be. There's no rule that says you can never have a square root in the denominator. Sometimes in high school, sometimes they teach you that just because they want you to get used to doing this. But it's not really a rule at all. It's only you only do it when your instructions tell you to, basically. Okay, that's it for that section.